Today, what we are going to do, class 9, subject physics, chapter number 5, as we are doing already. Topic of today's lecture is 5.4, which is artificial satellite, and that is page number 112 and 113. This is the last topic of chapter number 5. Again, I repeat, you open ninth class book, 112 page, 112 page. Topic is 5.4 artificial satellite. Today we are going to finish this chapter. Guys, can you open the camera for me, please? If you open the camera, please open the camera. Only boys will open the cameras. Please open. Boys, there is a request from you. Please open the camera. Boys only are requested. Okay. Class 9, subject physics, chapter number 5. Topic of today's lecture is 5.4 artificial satellite, that is on page number 112. Please open ninth class textbook, page number 112. Thank you. Today what we are doing unit number 5 as we were doing before, gravitation. The chapter name is gravitation. The today's topic is topic 5.4 artificial satellite. We are going to study, that is on page number 112. Please open page number 112. I'm saying again and again. And please turn on your cameras. Boys only. Turn on their cameras, please. Thank you. So today's topic is artificial satellite. An object that revolves around the planet is called a satellite. So first of all, I will give you the definition of the satellite. So, an object that revolves around the planet is called a satellite. Satellites are actually, satellite can be anything like planet, Earth is a satellite, Moon is a satellite. So Earth, Moon, these are all planets, called planets. An object that revolves around a planet is called a satellite. Satellites are of two kinds. One kind is natural satellite and other kind is artificial satellite. So I will tell you what is the difference between artificial satellite and the natural satellites. So this is the definition of the satellite. You can mark from here to here. An object that revolves around a planet is called a satellite. So there are the two kinds of satellite. One is natural satellite and other one is the artificial satellite. The moon revolves around the earth. You know, everyone know that moon revolves around the earth. So moon is the natural satellite of the earth. So I told you what is natural satellite. Since moon is revolving around the earth, so moon is called the natural satellite. This is the natural satellite. But if we consider artificial satellites are those satellites. Scientists have sent many objects into space. Some of these objects revolve around us. These are called artificial satellites. So I told you there are the two things. One is natural satellites, or one is the artificial satellite. Natural satellites, since moon is a natural satellite because this is created by Allah. So moon is a natural satellite. So since moon is revolving around Earth, so it is called natural satellite. But the satellites which are made by man are called artificial satellites. They are sent into the space for the purpose of communication. The television's programs comes to our televisions. This is due to the artificial satellites sent by the man to the space. These are called artificial satellites. Most of the artificial satellites orbiting around Earth, they are used for communication purposes. Artificial satellites carry instruments or passengers. There are some passengers in the artificial satellite to perform their experiment in space. Okay. What did I tell you? I gave you the definition of the satellite. Then I told you that there is a difference. There are the two kinds of satellite. One is artificial satellite, another one is the natural satellite. Natural satellites are those satellites which revolve around the Earth and they are created by Allah. So these are called the natural satellites. Since moon is revolving around the Earth, so moon is made by Allah. Moon is created by Allah. So moon is the natural satellite. But the satellites which are sent by the scientists for the communication purposes, they also revolve around the Earth. So these are made by the men. So for the communication purposes, that's why they are called the artificial satellite. The satellites which are made by man are called artificial satellite. The satellite which are made by Allah is called natural satellite. So artificial satellite, what they carry, they send into the space. They revolve around the Earth. They carry the passengers. They carry the instruments. So these are called the artificial satellite. So look at the figure. This is the artificial satellite which are made, man-made, and it is revolving around the Earth. Okay. So satellite. This is the artificial satellite, and it is revolving around the Earth. So this is at the height of this is at the height of h from the Earth. Okay, and r is the radius of the Earth, and this is the orbital radius. So this r is the small r is the orbital radius of the satellite, and this is the height of the satellite which is away from the Earth. So this is the capital R is the radius of the Earth. Okay. The satellite is orbiting around the Earth. Since this dotted line shows that this satellite is orbiting around the Earth, these dash lines are the space lines are shows that this satellite is revolving around the Earth. So it is at a distance of small h, at a distance of h from the Earth, and r is the orbital radius. Large number of artificial satellites have been launched in different orbits around the Earth. Large number of artificial satellites mean there are so many satellites which are launched in the space. Some are revolving near the Earth, some are revolving away from some are away from the Earth, some are near to the Earth. They are revolving some in a fixed orbits. This satellite, some may be revolving over here, so some is revolving down here. So they are revolving in different orbits. Large number of artificial satellites. This is the artificial satellite because this is made by man. Large number of artificial satellites have been launched in different orbits around the Earth. So this satellite is revolving in a different orbit. There are large number of satellites which are revolving around the Earth. They are not only a single or two or three. There are large number of satellites, artificial satellites made by man are orbiting around the Earth. So they take different time to complete their one revolution around the Earth. But revolution means if it starts from here, it will come back to this position again here. This is called one revolution. it is depending upon how far it is from the Earth. If it is in this orbit, if it is here, it's mean it will take longer time to revolve around the Earth. So if it is near to the Earth, so it takes less time to revolve around the Earth. So it's all always depending upon how far it is revolving around the Earth. Different artificial satellites takes different time to revolve around Earth because it entirely depends how far they are away from the Earth. They take the Earth depending upon their high distance age from the Earth. Communication satellites take 24 hours to complete their one revolution. The communication satellites are those satellites like the television programs comes from the which satellites they are called the communication satellites. These type of satellites takes 24 hours to complete one revolution around the Earth. And you know that as Earth also completes one revolution around the axis in 24, and you know the Earth revolves around the Earth revolves around the sun, and it also revolves around its own axis. So when it takes 24 hours to revolve around its axis, and you should know that when it takes 24 hours, when I talk about 24 hours, it's mean day and night changes. So when it takes 365 days to revolve around the sun. So seasons changes. Okay, you should remember this very clearly. The Earth revolves around its own axis, and Earth also revolves around the Sun. So when it takes 24 hours to complete one revolution around its own axis. But but when it revolves around the Sun, it takes 365 days. So 365 days mean it their seasons change. Okay, summer changes into winter, and winter changes into autumn. The season change because when the Earth revolves around the Sun, it completes 365 days to complete one revolution. But it also revolves around its own axis. When it revolves around its own axis, it means day and night changes. Okay, so you know that communication satellites uh, are very close to the Earth, and they take 24 hours to complete one revolution around the Earth. But similarly, the Earth also takes 24 hours to complete one revolution about its own axis. So hence these communication satellites appears to be just since it is they are taking the same time. Communication satellites are also taking 24 hours to complete one revolution around that, and Earth also takes 24 hours to complete one revolution around its own axis. So these time is same. That's why they are called the geostationary satellites, geostationary orbit. Dish antennas sending and receiving the signals from them have fixed direction depending upon their location of the Earth. You know, this is the communication. These antennas are tuned. This antennas are fixed on your floor or your roof. They are fixed at a fixed position in order to capture the sending or receiving the signals from these satellites. So I told you communication satellites are sent into the space for the purpose of communication, for the purpose of television programs to be broadcast. So I told you different artificial satellites and made by the man are sent to the space, or they revolve around the Earth for the purpose of communication. So the important thing about the MCQ's point of view, the MCQs comes in the board examinations. So these boxes, do you know? Do you know? These boxes comes. They are important for the MCQ's point of view. What is said in this box? The height of the geostationary satellites is about 42,300 kilometers from its center of the Earth. Its velocity with respect to Earth is zero because they are taking same time So that's why the velocity is taken as 0. But global GPS, what is GPS? Global Position System. GPS stands for Global Position System. Is a satellite navigation system. It helps us to find the exact position of an object anywhere on the land, on the sea, or in the air. Whether the object is in the land or in the sea or air, with the help of the GPS, Global Positioning System, we can we can find its exact position. So the purpose of the global positioning system is to help the exact position of someone, whether he is in air, he or she is in air, land, or anywhere in the land, in the earth. GPS consists of 24 Earth satellites. These satellites revolve around the Earth twice a day. It means it takes twice a day with a speed of 3.8 kilometers per second. I told you these two boxes are important because they are very important according to the MCQ's point of view. So you should know what is geostationary orbit and what is geostationary orbit and how far they are from the Earth and what is their velocity with respect to that. And I told you about the GPS global positioning system, the use of global positioning system. Global positioning system is actually used to find out the exact position of any object anywhere in the land, on the air, on the air, or in the sea. So you should be very clear these two boxes are important for the MCQ point of view. So 5.4, now I'm moving towards motion of artificial satellite, which is on page number 130. As the starting of the lecture, I told you we are doing 5.4 artificial satellite, topic artificial satellite, which is on page number 112 and 113. This is the last topic of this chapter. Okay. So after this, we will chapter 5 will finish and we will do the MCQs and numerical related to this chapter. Okay. So this is the last topic of chapter number 5. Motion of the artificial satellite. So motion of the artificial satellite, I read that a satellite requires centripetal force that keep it to move around the Earth. The gravitational force of attraction between the satellite and the Earth provides the necessary centripetal force. A satellite requires centripetal. As I told you in the earlier chapter, in my earlier chapter, we studied about centripetal force. I know whenever the object is moving around someone, or it is moving in a circle, it requires centripetal force to keep it moving. Similarly, the satellite which are revolving around the Earth, they require the necessary centripetal force provided by the Earth. Okay, that revolves around them, revolves around the Earth. The necessary centripetal force is required. The satellite which is revolving around the Earth, it requires necessary centripetal force to keep moving around the Earth. The gravitational force of attraction between the satellite and the Earth provide the necessary centripetal force. As I told you, this artificial satellite is revolving around the Earth. This is the Earth. This one is the Earth, and it is revolving around the Earth. So it requires whenever the object is revolving or moving in a circle or in an elliptical path, it requires some force. That force is called centripetal force. We have already discussed in our earlier chapter what is centripetal force. So centripetal force is the force which keeps the body moving in a circle. Okay, so since this satellite is revolving around the Earth, so the centripetal force is provided by the Earth. So you know that centripetal force, consider a satellite of mass m. Uh, this satellite, mass of this satellite, suppose this mass of this satellite is m. Okay, and revolving around that at an altitude h. As I have already told you, this is the distance from the this satellite is revolving at a distance of h, and its radius, orbital radius, it is called r naught. Or r naught means orbital radius. I show you now. This is orbital radius, and this is height, and this is the mass of the satellite. So if you know the centripetal force, that the formula for the centripetal force, which we have already discussed in our earlier chapter, you know the centripetal force is the force which keeps the body moving in a circle. So Fc, since satellite is moving around the circle, so that means necessary centripetal force is required by the Earth. So FC, you know, FC is equal to mv naught divided by r naught. Their formula is mv squared divided by r. But since we are talking about orbital velocity and orbital radius, that's why I'm placing mv naught and r naught. The formula is same. Centripetal force formula is FC mv squared divided by r. If you read the last chapter where we discussed where we find centripetal force, we studied about centripetal force. The formula is Fc is equal to mv squared divided by r. But since this satellite is revolving around the Earth, then excessive centripetal force is provided by the Earth. So our centripetal force formula is only changed. Fb naught is the orbital velocity, and r naught is the orbital radius. This formula will be same. You know, F is equal to W, and W is equal to mg. And you know this already. Since the satellite is at a height h, that's why I'm placing small h. So I will place mgh in this formula. Fc is equal to mgh. I will replace Fc is equal to uh, mgh. Fc is equal to mgh. mv naught square divided by r naught will be the main axis. You know, m will be cancelled with, why this m is cancelled? When, because here it is multiplying. If it goes down, it will be divided. So m will be cancelled with this m. So what will be rest? We are separating out v naught. We are separating out from here v naught. So v naught square is equal to gh r naught, right? If you multiply this, m will be cancelled with m. So gh cross multiply gh r naught. So v naught m is cancelled out. So v naught square is equal to gh r naught. If you take the square root on both sides, because I want to find out the orbital velocity, so I will take the square root on both sides. So if you take the square root of the both sides, this square will be cancelled out with 1 by 2. Square root, value of square root is 1 by 2. So this square will be cancelled with 1 by 2. So if V naught is equal to orbital velocity is equal to gh r naught. If I consider r naught is equal to r plus h, orbital, if I go back, r naught is equal to, r is the radius of the Earth, where r is the radius of the Earth, and h is the height of the satellite where it is revolving around the Earth. So our r naught orbital radius is equal to r plus h. I just substitute values. R naught is equal to r plus h in 5.10. So r naught is replaced with r plus h. So v naught is equal to gh r g. I am putting this r naught is equal to r plus h in 5.10. So gh is equal to r naught. R naught is equal to uh, sorry, r naught equals to r plus h. Equation 5.10 gives the velocity which satellites must possess when not in an orbit of radius r naught is equal to r plus h around the Earth. An approximation can be made for a satellite revolving close to the Earth, such that if the satellite is revolving, if the satellite is at a height of at some height from the Earth, then this equation will be written. But if it is very close to the Earth, then h is not to be considered because it is very close to that. So we will take r only. So r plus h will be only r. So our gh is equal to g, because it is when the satellite is revolving around us very close. Then our height, we will take the radius of the Earth, and gh is equal to nearly equal to g. So our v naught, this v naught will become gh is, I'm going to replace gh is equal to g, and r plus h is equal to capital R. So v naught equals to under root g our R. Our R. A satellite revolving around very close to the Earth has speed v naught nearly 8 kilometers per second, or in kilometers per hour it will be 29,000 kilometers per hour. Okay, so this is we discussed motion of the artificial satellite. We discussed about the motion of the artificial satellite, and we discussed about the what is artificial satellite and what is. I repeat the all things for you now. This is the end of the chapter. So 5.4, we discussed about 5.4 today's, which is on page number 112. Okay, so artificial satellite. First of all, we define what is satellite. An object that revolves around a planet is called satellite. If they ask you, if the board examiners ask you what is satellite, then you will have to give the definition. An object that revolves around a planet is called a satellite. So there are two kinds of satellites. One is natural satellite and other one is artificial satellite. What is the difference between natural satellite and the artificial satellite? Artificial satellites are the satellites which is made by Allah and they are revolving around the earth. They are revolving since the moon is revolving around the earth and moon is made by Allah or created by Allah. So moon is called the natural satellite. But on the other hand, if we talk about artificial satellites are made by man, and the man send uh, these artificial satellites for the communication purposes into the space. Since they are made by man, so this is called artificial satellite. Then we talked about large number of satellites are sent into the space and they are revolving around the Earth in different orbits. They are revolving around the Earth in different orbits. So they some are moving very close to the Earth and some are moving very away from the Earth. If they if they are moving very close to the Earth, they are called the geostationary because some satellites takes communication. The satellite which are sent to the space for the communication purpose, they move very close to the Earth. So they takes 24 hours to complete one revolution around the Earth. But Earth also takes 24 hours to complete one complete revolution about its own axis. Since their time is same, so they are called the geos. They are these satellites. The artificial satellites are uh, revolving around very close to the Earth, so they are called geostationary satellites. They are called geostationary satellites. Dish antennas actually we place on the top of our roof. What they do, we position them on the position of the satellites on the communication satellite. Okay. Then we talked about motion of the artificial satellite and motion of the artificial satellite. A satellite requires, I told you in the earlier chapter, what is centripetal force. Centripetal force is a force which keeps the body moving in a circle. Since this artificial satellite is revolving around the Earth, so necessary centripetal force is provided by the Earth. Okay. So the formula for the necessary centripetal force is Fc mv square divided by R, and since v naught is the orbital velocity, since we are facing the satellite which is moving with the orbital velocity which has some velocity. So let's say the velocity of the artificial satellite is v naught and it is orbital radius is r naught. So our formula of necessary centripetal force will become Fc is equal to mv naught square divided by r naught. Okay, and F is equal to W and W is equal to mg. Since this artificial satellite is moving at some height from the Earth, that's why I'm writing GH. Okay, so Fc is equal to mgh. So I will put mgh in this equation. So Fc will be replaced with mgh. Mv naught square over R naught will be as it is. Then m is multiplying here. If it will go down, it will be divide. M will be cancelled with this M. So what is left? And I'm going to separate out V naught. So V naught square is equal to GH R naught. G naught will be equal to R naught. So V naught square, if I take that because I want to take orbital, I want to find out orbital speed. So orbital speed, I take the square root on both sides. So take the square root over here. So V naught is equal to GH R. If I R naught is equal to R plus H, if the satellite, artificial satellite is moving away from at a height of H from the Earth, so our orbital radius will be R plus H. Just substitute R naught is equal to R plus H in equation 5.10. So R naught over here will be replaced with R plus H. So V naught, our orbital velocity will become this equation 5.10 will become this R naught. I'm just placing R naught is equal to R plus H. GH R plus H. Equation 5.10, this equation 5.10 gives the velocity which satellite must possess when launched in the orbit of the radius disk around the Earth. If the satellite wants to revolve around the Earth, this velocity uh, must be must be possessed. The satellite must possess this velocity to launch around the Earth. An approximation can be for a satellite revolving close to the Earth. If the satellite is revolving very close to the Earth, it means then the radius of the Earth will be considered, and there will be no height because the height is it is moving very close to the Earth. So our R is greater than, so R plus H is equal to R. I'm just putting R plus H is equal to R, and since it is this satellite, this artificial satellite is very close to the Earth, so there will be GH is equal to G. So our orbital velocity is equal to G. GH is replaced with G, and R plus H is equal to R. If the satellite is revolving very close to the Earth, then orbital velocity will be this. If the satellite is revolving at some height, then our orbital velocity will be 5.11. If the satellite is revolving close to the Earth, then our equation will be 5.12. And if the satellite is revolving away from the Earth and at some height it is revolving, then our equation will be V naught is equal to GH R plus H. Okay, that's the satellite which is revolving and very close to the Earth. It is moving with the orbital velocity nearly 8 kilometers per second. Okay, it is moving 8 kilometers per second or 29,000 kilometers per hour. This is a smaller unit, kilometer per second, and this is the bigger unit, kilometer per hour. If you convert kilometer per second into kilometer per hour, you will find that it will be 29,000 kilometers per hour. The satellite which is revolving very close to that, it must be moving with the orbital velocity 8 kilometer per second or in 29,000 kilometer per hour. So this is the students. This is the end of the chapter number 5. In our next lecture, we will do the MCQs and numericals. Hopefully, few numericals of this chapter. So your homework is please do write once your rough register the topic covered today and memorize the topic by heart. We talked about your homework is satellite, what is satellite, definition of satellite, then what is natural satellite, and what is artificial satellite, and then we talked about this is the motion of the artificial satellite, drive the equation, motion of the artificial satellite. You need to do these write down these two topics, 5.4 artificial satellite and motion of the artificial. You need to drive motion of the artificial satellite on the rough register, and you need to write once the definition of satellite, artificial satellite, motion of the and natural satellite, and what is geostationary orbit. So you need to memorize all these things, and you need to drive the equation which we discussed and practice them on your rough register. I hope you understand this topic. If you don't understand this topic, please let me know. Feel free to ask me the question. The more question you ask, the more you learn. It's mean please feel free to ask. I'm ready to help you. I'm ready to give you answer your questions and ready to answer all these questions